Now let's see some programming techniques. Uh, and according to our curriculum, the 6.4, the 6.4 what is programming programming using counter techniques. Programming using counter techniques. First, the program. First one is write a program to sum up given n numbers. Write a program. Write a program to sum up write a program to sum up given n numbers. The length of the series in the memory location. These n numbers are stored in 2200H memory location, and series itself begins with the memory locations 2201. The length means how many numbers. Let us take n numbers. If it is n is equal to 10, and this 10 will be stored in 220H, and series starts from 2201H. This is what the problem explains. And assume the sum to be 8-bit numbers. So the total sum of all these 10 numbers, after adding all these 10 numbers, the sum should be 8-bit only. So we require 8-bit registers. So you can ignore so 8-bit means ignoring carry can be ignored. Carry can be ignored. And store the sum. Sum will be stored in 2300H. This is the problem. First, write a program to sum of given n numbers, and whose n numbers, the total numbers will be stored in 220H locations, and series starts from 2201H locations. If it is n is equal to 10, total 2201H2 2210, total 10 numbers will be stored in all these series of locations, 22012 to 2210H locations. Correctly, 10 numbers will be stored. And next, after assumption is the assumption is given here. The sum of these 10 numbers, 10 given numbers, is only 8-bit. So therefore, carry can be neglected, and the total sum, the final result, will be stored in 2300H. For this problem, first we'll draw the flow chart. Here, first we'll draw the flow chart. I'll take a red here to draw the flow chart. But say for any flow chart, first step, what should be? It should start with well. This is start. After start, first here we require a sum, right? So this is the addition program, sum of n numbers. The sum is equal to 0. So we don't know where exactly this sum initial. If sum is not equal to 0, in previous operations, it affects our results. So initially we need to initialize the sum register to 0. And we require a pointer. Why? Because the numbers will be stored in arrays. The pointers is equal to 2201H. And next, counter. The count how many number of will be stored in 2200H, and this is a counter. For this counter, we can decrement the counters. So therefore total 10 numbers will be added together. And next, after this initialization and sum clearance, what arithmetic operations has to be carried out. This is sum is equal to sum plus sum 0 plus the value which is present in 2201H. 201H pointer. Okay, the content of 2201H is added to the sum 0 like this. After this, pointer is incremented by 1. Why? Because next number to be added to the sum. So pointer should be equal to pointer plus 1 should be incremented by 1, or counter should be equal to decremented by 1. Count minus 1. Next is the condition. If the count is equal to 0, count is 0, then S means stop. Results will be stored in sum will be stored in 2300H location. Otherwise, if it is not, then again do sum operation. Like this. Better. Yeah. Again sum. Now here, after this pointer is initially it is 001. Now for the second iteration, this is sum place at the rate of 2202 and second iteration. And third iteration, this is sum place at the rate of 2203. And sum every time the sum will be updated like this, updated with the new results. And this sum at the rate of next array point is 220. And so on up to sum place at the rate of 2210. This is a lost location number which should be added to this sum. And each and every sum operations, the counter is decremented by 1. Initially it was previously it was 10, now become 9, 8. If it is 10, if 10 numbers, addition of 10 numbers, 9, 8 and 7, here it becomes 1. After that it become decremented to 0. If the count is 0, yes, condition is satisfied. The gem is the sum will be stored in 23 locations. And next, end. This is the first. This is all about flow chart of sum of n given numbers. Sum of n given numbers. Now we'll see uh, program part of this. Here, this flowchart is completed. Now, writing a program. Program can be written like this. Here, the now program. I'll take this green color. Program sum of n given numbers. First, we require a pointer, right? So therefore, where the count value will be there to move dptr data pointer immediate data. This is 2200H. This instruction, what the 2220H is loaded into dptr register. So we are not just initializing the data pointer. Now, what the contents which are present in 220 is total numbers. How many numbers we are going to add that is present in 220H. Therefore, we need to uh, take the contents of 220 locations to some register to act as a counter. So therefore, move x, this is the external address. So external address move x a comma at the rate dptr. What is the dptr is loaded with 220H. At the rate DTTBR, the contents of 220H locations will move to accumulator. Now, accumulator we are using for addition purpose. So therefore, the content, the total numbers, the series of numbers, total number, how many numbers will be present in total series is present in 220H location, which is transferred to the accumulator. Now, from accumulator to we need to send one register to act to make it as counter. Now here R0 is acting like a counter. R0 as counter. Next counter value is there. Next series is present in 2201 locations. Therefore, we need to increment DPTR. Increment DPTR. DPTR incremented. Once a DPTR incremented, what we need to do? We have to take another register to store the sum. So therefore, move. I'll take R1 comma hash 00H. Okay, but every time the sum will be stored in accumulator. So therefore, accumulator should also be cleared. So then for that process, what I'll do is I'll send this 00H content to the accumulator also. Now, so can after this instruction, I can also write move a comma R1. So what are the contents of R1? 00H. 00H contents will be moved to the accumulator. Okay, accumulator is also cleared. So each and every arithmetic operation, accumulator contents are updated. The results is updated. So therefore, accumulator contents is also updated. Next, content will be see. I'm getting the content from DPTR. So move X here. I'll take eraser here. Yeah. This is move X a comma at the rate DPTR. What are the contents of DPTR? DPTR. Now here DPTR is incremented. It incremented to 2201 locations. Now the contents of 2201 locations will move to accumulator. Now what happens? Accumulator. Now accumulator contains first number of series. Accumulator contains the first number of series added with some register. I'll read this. This is here. This is add a comma R1 means the contents of R1 is 00H and contents of A is a series of first number of series, given series, sum of n numbers. Not the exact series, there's some numbers, some random numbers will be given and which is stored in 2201 locations too, and so on. Where if it is n, that n is the total numbers which is stored in 2200 locations. Now here a R1 comma a. Now accumulator has a sum. So now what we need to do? We need again move this sum accumulator to R1 register. So move R1 comma a. So the contents of addition of first addition, the sum will be stored in R1 again. This operation has to be repeated until all series of numbers will be added together. So therefore, move R1 comma a, the contents of the sum will again will be loaded into R1 register. Next, what we need to do, we have to increment DPTR again. Increment DPTR. If we increment the DPTR, now it jumps to which location? This jumps to 2202 location. DPTR is incremented. Now the counter value is stored in R0 register. So we need to decrement counter, decrement and jump on no zero. PJNZ R0, decrement R0 register, and if R0 is not equal to 0, jump to a specific location. And which location it is? Jump to, we need to up. ఎక్కడికి up jump చేయాలి? Add a1 comma, sorry, move. Okay, this is up. This is a label address. ఇక్కడ జంప్ అవ్వాలి, ఇక్కడ నుంచి ఇక్కడికి జంప్. అప్పుడు ఏమైతే move x again accumulator. What is the dptr is now presented. The data pointer shows the 2202 locations. The contents of 2202 locations is again comes to accumulator. Now accumulator contains and previous addition results, which is stored in R1 register. Now R1 add a comma R1. The contents of 2202 location is loaded into accumulator. Now accumulator contents is added with R1 register. R1 register previous results is updated with the previous results. So previous results is added with another number of another number in a given series. Therefore, now again accumulator contains the results. The accumulator again sends to R1 register. R1 register is a sum register. Sum will be stored in R1 every day. Again increment dptr. Now dptr is incremented to 2203. Now 2203 is incremented. dptr is incremented. It points to the next data pointer. Now decrement R0. If R0 register, we don't know what's the value of R0. Let us take for understanding, it is 3. First operation is completed and decremented R0. It becomes 2. Now second operation is also completed. After again it decremented to 1. 1 is not equal to 0. Again jumps to up. So again now move x a comma at the rate dptr. What is the location of dptr present? 2203. Now the contents of 2203 location is moved to accumulator. Now accumulator, now the content, the add a comma R1 will do lost content of data pointers array data array and updated sum which is present in R1 register. These two numbers will added together, and again sum will be moved to R1 register. Again increment dptr. Now dptr will be 2204 and decrement R0. So R0 is 1. Again it is decremented to 1, decremented to 0. So jump on no 0 to up. But if it is R0 is equal to 0, so therefore what happens? Once if R0 is equal to 0, we need to again pointer. The result should be stored in 2300. So therefore move dptr, come on, at the rate 2300h. Data pointer is loaded with 2300h. Now where the result is stored in R1 register. So again we need to send R1 directly. The contents of R1 register cannot send to the 2300h locations. Therefore, first we need to transfer the contents of the sum which is present in R1 register to accumulator. So therefore, here review. Here move where the result will be stored in R1 register. So therefore move a comma R1. Now we are getting result into the accumulator. Then next move x at the rate dptr comma a. Now result will be stored in accumulator. We get into the result into the accumulator. Now accumulator results, contents of accumulator will move to the dptr, which shows the pointer of 2300. Over. So what he asked, he given 10, he given some series of numbers. Let us take these numbers will be stored. 2200, let us take 10. Means what he given problem? This is a total 10 numbers are there. We need to add each and every numbers. And 2201 is I'll write the series like random numbers 4, 2202, 3, 2203, 1, 2204, 5, 2205, 6, 2207, sorry 6, 2206, 1, 2207, 2, 2208, 0. How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8. Instead of 10, make it as a 8 only. అంటే 220లో ఎన్ని నెంబర్ సిరీస్ ఉందో 8 నెంబర్ సిరీస్. ఆ సిరీస్ ఏమేమి ఉన్నాయి 4, 3, 1, 2 అనేది డేటా అరేలో స్టోర్ అయి ఉంది. డేటా అరే ఈ అరేని కాల్ చేస్తూ ఉండాలి ఎవ్రీ టైం. ఇప్పుడు ఏం చేసినాం మనం ఇక్కడ సింపుల్ గా ఎక్కడి నుంచి స్టార్ట్ అవుతుంది పాయింటర్. సో 16-bit పాయింటర్ కాబట్టి మనం ఇమీడియట్ డేటా పాయింటర్ మూవ్ చేసినాం 2200. అప్పుడు now data pointer is loaded with 220 location. Now we require the contents which is present in 2200. 2200 లో ఏ కంటెంట్స్ ఉన్నాయో అవి మనం అక్యుములేటర్ తీసుకురావాలి, రైట్. సో ఎందుకనంటే ఇక్కడ లెంత్ ఆఫ్ ద సిరీస్ ఇస్ మెన్షన్ చేసింది, అప్పుడు అక్యుములేటర్ నెంబర్ వాల్యూ వచ్చింది. నా అక్యుములేటర్ నుంచి ఏదో ఒక రిజిస్టర్ either it is R0 to R7 ఏదైనా తీసుకోండి. R0 రిజిస్టర్ ఇక్కడ కౌంటర్ లాగా యూజ్ చేసినాను. ఇక్కడ ఉంది 220లో ఏముంది @220 అంటే కంటెంట్స్ ఆఫ్ 220 లొకేషన్ ఈజ్ 8. ఇక్కడ దిస్ ఇస్ 8. ఈ 8 change the color. See, this is 8 is there. Now 8 is loaded into R0 register. R0 లో ఏముంది 8. Next, increment DPTR. Initially DPTR is at 220. Now it is incremented to 2201. Next, we require one register to store the sum. So initially, if there is any value is present in R1 registers, maybe might be there for previous operations. So first of all, we need to clear some register. Then move @a, DPTR. Means this is the contents of DPTR. What are the contents of DPTR? DPTR is points to 2201 location. Now the contents of DPTR, see at 2201. 2201 లో ఏముంది 4 అక్యుములేటర్ కి రావాలి. అక్యుములేటర్ లో ఏముంది 4 ఉంది. నెక్స్ట్ యాడ్ a, R1. R1 లో ఏముంది 00 ఉంది. R1 లో 00. యాడ్ a, R1 అంటే 0 + 4 is equal to 4. Now again move a, see here this result will be again stored in accumulator. అక్యుములేటర్ లో 4 ఉంటాయి. అప్పుడు ఏం చేస్తాం మూవ్ R1, A అన్నప్పుడు అక్యుములేటర్ లో 4 అనే డేటా ఉంది, ఆ 4 R1 లోకి పోయింది. నెక్స్ట్ ఇంక్రిమెంట్ DPTR ని చేసిన. DPTR చేస్తే అప్పుడు ఏముంది 2201 అంటే ఇప్పుడు ఏమో 2202 ఉంది. 2202 ఉంది. కౌంటర్ ఇంక్రీజ్ అయింది, సారీ పాయింటర్ ఇంక్రీజ్ అయింది. ఇన్ని లొకేషన్స్ ని మానిటర్ చేయడానికి పాయింటర్ ఇంక్రీజ్ అయింది. బట్ R0 రిజిస్టర్ లో ఏం పెట్టినాం మనం 8 పెట్టినాం. 8 తర్వాత ఏం కావాలి డిక్రిమెంట్ R0 రిజిస్టర్ అంటే ప్రీవియస్లీ ఇట్ వాజ్ 8, నౌ ఇట్ ఈస్ 7. సో R0 లో ఏం కావాలి 7 అవుతుంది. R0 లో 7 అవుతుంది. 7 is not equal to 0. So therefore jump up. ఎక్కడికి జంప్ అవ్వాలి? అగైన్ మళ్ళీ move x a, @DPTR. Again, what is the DPTR location? ఇక్కడ ఇంక్రిమెంట్ అయిన తర్వాత DPTR లొకేషన్ ఏముంది 220. 2202 లో కంటెంట్స్ ఏమున్నాయి 3 ఉంది. ఆ 3 ఎక్కడికి పోవాలి అక్యుములేటర్ పోవాలి. నా అక్యుములేటర్ పోయి అప్పుడు అక్యుములేటర్ తర్వాత నెక్స్ట్ ఇన్స్ట్రక్షన్ ఏంటిది యాడ్ a, r1. r1 లో ఏముంది 4 ఉంది. a లో ఏముంది 3 ఉంది. సో therefore 4 + 3 = 7. Now 7 is accumulator లో మళ్ళీ ఇప్పుడు 7 అప్డేట్ అయింది. 7 accumulator contents again sent to r1. So therefore ఇక్కడ 7 కాస్త 4 కాస్త 7 అవుతుంది. నెక్స్ట్ ఇంక్రిమెంట్ పాయింటర్ అక్కడ ఏమైతుంది 2203 220. నెక్స్ట్ డిక్రిమెంట్ ఆర్ నాట్ రిజిస్టర్ previous it was 7, now it is 6 is not equal to 0, again jump here. Move x a comma at the rate dptr ఏముంది 2203 లో ఉండే కంటెంట్స్ 2203 లో ఏం కంటెంట్స్ ఉన్నాయి 1 ఎక్కడికి పోయింది అక్యుములేటర్ నౌ యాడ్ a comma r1 అన్నాం అనుకో r1 లో ఏముంది 7 ఉంది, a లో ఉంది 1 ఉంది. సో therefore 7 + 1 = 8. అక్యుములేటర్ లో 8 వస్తుంది. మళ్ళీ 8 ని తీసుకుపోయి r1 లో పెట్టాలి. r1 నేను అగైన్ ఇంక్రిమెంట్ DPTR లో 2204 అవుతుంది. 2204 అవుతుంది. డిక్రిమెంట్ ఆర్ నాట్ లో ప్రీవియస్ గా 6 ఉండే ఇప్పుడేమో 5 అవుతుంది. 5 is not equal to 0, అగైన్ జంప్. అప్పుడేముంది DPTR లో ఏముంది 2204 DPTR లో వాట్ ఆర్ ద కంటెంట్స్ 5 will be loaded into accumulator. నెక్స్ట్ 5 + 8 ఇక్కడ a, r1 లో 8 ఉంది, a లోనేమో 5 ఉంది. సో therefore 5 + 8 = 13. క్యారీ ఎలిమినేటెడ్ ఎందుకంటే ప్రాబ్లం లోనే ఇచ్చాడు కాబట్టి ఓన్లీ 3 ఉంది 3. నెక్స్ట్ ఇంక్రిమెంట్ DPTR 2205. నెక్స్ట్ డిక్రిమెంట్ ఆర్ నాట్ this is 4. Like this it iterates all operations, and once it is 0, here it jumps to 0. Jump if or not is not equal to 0. If it is 0, next instruction will continue. ఇక్కడ ఏంది సమ్ ఉండాలి కదా, సమ్ ఎక్కడ అప్డేట్ అవుతుంది r1 లో అప్డేట్ అవుతుంది. సో r1 లో సమ్ తీసుకెళ్ళి 2300 లొకేషన్స్ లో స్టోర్ చేయమని చెప్పాడు కాబట్టి మనం ఏం చేయాలి పాయింటర్ ని మళ్ళీ పాయింట్ చేయాలి. సో therefore move DPTR as 2300h. ఎక్కడ ఉంది రిజల్ట్ r1 లో ఉంది. r1 లో నుంచి అక్యుములేటర్ తీసుకురావాలి. అక్యుములేటర్ లో ఉన్న డేటాని ఈ 2300 లొకేషన్స్ కి పంపించాలి. సో therefore move x at the rate, this becomes a destination, this becomes source లో సమ్ రిజల్ట్స్ ఉంది కాబట్టి సమ్ నుంచి డెస్టినేషన్ at the rate DPTR మీన్స్ 2300 లొకేషన్ లోకి మన సమ్ ని స్టోర్ చేయాలి. దాని తర్వాత s జంప్ హియర్ ఇక్కడనే జంప్ అవుతుంది. సో దిస్ ద end of the instruction, end of the program. Like this we can add series of n numbers and some will be stored in 2300h locations. This is all about first program.